science standards came out, I was really excited to see that a lot of this we're already integrating into our classrooms. And elementary school teachers sometimes view new standards as something scary and something else that you have to do. However, we don't want to make you feel that way. This is something that you're already doing as a teacher, because let's give it a, you know, what it is. Teachers are the best actors and actresses. We interesting and more fun than they normally are. So these are some ways that you're going to sneak these science standards, computer science standards, into your classroom without putting a whole lot of effort and work into it. I have with me today Lisa Bond. She is a TRT for our division. Lisa, you want to introduce yourself?
Yes, and I've been involved with coding at some level probably for 15 years. We really love this. I love it. She's keeping her eye on me today because I tend to blab. And I tend to, because I'm excited, I want to tell you everything I know about it. So she's going to be here clamping me every so often, saying, Lisa, we're moving on to the next item now. But something we wanted to find out is, why are you all here today? Why did you choose to come to see us? I know you just wanted to see us, but why did you come?
Anybody want to share a reason why?
Just a little bit of explanation about some of the wording, the vocabulary is a little bit confusing, I think, for somebody that doesn't teach computer science.
Right, right. And I don't have a computer science background either. So everything I've learned with my kids over the last couple of years as we have integrated the coding into our classroom. Sure.
It's a very cross-curricular topic, so it's something that I can share with everybody.
Absolutely. And that's what we hope that everybody gets out of this presentation, is that it's something they can share cross-curricular. Yes, sir.
As an ITRT in my county, we're trying to create resources for teachers of how they can integrate into their ideas.
We hope that you will gain those as well. Our presentation will share it on the VSTE site, so all the awesome.
And that we probably right after this is over.
Yes.
We've got them all ready to go.
Yes. So we want you to know our little secret. You're already teaching this. You're already sneaking them into your curriculum, even though you may not touch a computer or an iPad or a Chromebook or something all day long. You are teaching the computer science standards every day, whether it be reading, math, social studies, or history. So it's not something else that you're going to have to do. You may want to add some new things into your repertoire of teaching skills, but you're already teaching these things. The goal of today's session: you are very good at sneaking in information that's necessary for student achievement. There are some things that kids don't even realize they're learning from you, but you have snuck that in, whether it's a life skill, a math skill, a reading skill, a history skill, anything like that. You may feel like you've been tasked to teach something else, and in all reality, you're already teaching these, but you can enhance these skills with some little tips and tricks and technology in the free program that we're going to show you today. Go ahead. Okay, the premise behind the standards. Computer science standards were developed by one of the sessions I actually watched yesterday. They've kind of always been around, but they weren't like their own separate standard. So we want to encourage students to develop, design, and execute a plan. I see, as a math teacher of 6th graders, the struggle of students to start from one point and actually get to a finish point, like thinking about like problem solving, multi-step word problems. They have a really hard time interpreting what to do with that. So we want to encourage students to decompose large problems into smaller pieces and follow through with a solution. Sometimes they can get part 1, but they don't finish and answer part 2. And we know the SOL, if it's multiple choice, they're going to have the first answer, the first step, and the answer to the second step. So if they stop with that first, they're going to ultimately get it incorrect. And we want to encourage students to use technology safely and appropriately. And I think this is a big thing. With the social media pushes that we have, and the cyberbullying and the peer pressure and all of those things that are occurring, I mean, I have issues with my 6th graders with this sometimes. It occurs outside at home on House Party or Kick or Instagram or whatever, and then they bring it into school and it creates a problem in the classroom. So helping them to learn how to use it safely and appropriately is also another big facet of these computer science standards. All right.
What is computer science? All of a sudden when we hear that, we think that we have to be computer scientists. Let's pretend I'm a kindergarten teacher. Most likely I'm not, haven't studied computer science. Some popular definitions include the studies of principles and uses of computers. Okay. Studies that deal with the theory and methods of processing information, digital computers, design of computer hardware and software, and applications of computers. Okay. Computer science is the study of computers and computing concepts. It includes both hardware, software, as well as networks of the internet. I like the last one best. I think that probably discusses it a little bit more. I also have down here what I have, what I think it is. And I think computer science is the interrelationship between humans and hardware or software to get work done. When I walk into a classroom, I have a different perspective. I'm a TRT, ITRT, but I was in the business world for 16 years before I entered into the education field. And one of the reasons I came in is I wanted to help prepare students for the future and the workplace. So every time I go to the classroom, I look at a little child, maybe 3 or 4 years old, and I'm saying, I want that child to get a job, and a good job. So you all may have other expectations too along with that, but when I go in, that's what I'm looking for. With that little child who's maybe sticking their finger in their neighbor's ear, I'm hoping that that child maybe is a future ENT, and they're already practicing their skills. You may know differently.
Okay, so if you've taken a look at the computer science reporting categories, they're split into, like, we have number and number sense for math and geometry and all that. So they're split into algorithms and programming, computer systems, cybersecurity, data and analysis, impacts of computing, networking, and internet. And these go K-12. We're going to focus today on K-6 is what we're looking at today. So what we're going to do is kind of break these down per report category and give you some examples of some things that you're already doing in your classroom or you could do in your classroom to help you cover these reporting categories.
All right, and I've been charged with K2s. And let me tell you, the K2 standards, if you're K2 teachers, anybody K2 teacher in here? We only have one?
Two. There's one.
Two? Okay. Well, I'm going to be grabbing you later. With K2, believe me, you know more computer science than they do. So already we're demystifying it a little bit. You're going to be fine. And you may say, well, my kids know so much. They, pick up a tablet and do all kinds of things. Well, they can pick up a tablet, but they don't necessarily know what is the proper usage or really have knowledge of the functioning of it. They just know how to get to the game, get it open, closed, something that an older implementing the K2 standards, if you're afraid, which I hope you're not, but if you were, you could go to Codeorg's Computer Science Fundamentals, course 1 through 4. I have it loaded in the presentation. It gives you step-by-step activities that cover all the standards, except for, it does cover some of the internet safety and all, but I think with K2s, how many of you are familiar with things like NetSmarts? That's much more little kid friendly than some of the, the other ones are a little bit more involved maybe on Code.org. So certainly you could take care of your computer standards in a very basic level way by just following the information in here. It also has worksheets. Their unplugged activities are great if you don't have a lot of equipment in the room. So there you are. You can do it for that, but I've given you some other things too. Usually when I teach something, computer science, robotics, coding, I tend to do it whole group to begin with so that we all kind of get the same kind of foundation together versus just handing you a tablet and say, best of luck, see you later, and then maybe you'll come up with something. I feel they need to have that work together. I also, if you have a panel in your classroom or a touch board of some sort, is I do some basic coding together on Code.org. I love the Angry Birds for working with little kids. I also believe in physically coding, and that means that I'm using my body to actually walk through the steps. We have the little bird on the screen doing it. We have the little squares in the classroom doing it also, using different directions, different steps, loops, anything like that, because it gives the kids really a physical understanding of what they're doing. Versus like, oh, I'm just going to get that bird and avoid the dynamite. We want to make sure that they can actually feel and know what they're doing. And I kind of call that, and I'm jumping a little ahead, I call it touch, feel, experience. That's how I teach robotics. Is you've got to touch the equipment, you got to see it, feel it. And when I'm talking about feeling it, I don't necessarily mean that I'm feeling the technology. What I'm talking about is that I feel it in me, that I really know what I'm aiming for and what I want to do. And then I've got to have the experience of actually doing it. When I start teaching computer science or robotics, I make sure that the little kids get a chance to, I'm trying to stay in and make sure that I'm still in the field of vision, because I'm a mover and a talker. I want to make sure that they get an experience. I'm all for working in a group in pairs, and I like the pair idea, but I want to make sure that everybody at the beginning gets a chance to touch and see everything else. Because as we know, people that are very talented in something, sometimes they will want to take over the information. So I want to make sure at the beginning that everybody has some success and a feel for it. And the standards, as you all see, they're very basic in K through 2. We build on them each year. And, but I said, it's pretty low level. You all can do this. And it can be a lot of fun. Now, what I've done here with my little sneakers is I've attached to each of those a little spreadsheet. And let's go with K.
Nope.
Oops, wrong
Okay.
one. It hit right on that.
No, it didn't.
No?
Okay, that's okay. I can
Well,
take
just
you to the folder.
imagine.
I can take you.
Just imagine. It's in the folder.
We'll get you where you need.
Yes, and it was working before. I went ahead and put that in, and then I put different enhancing activities in it afterwards. For example, the student will conduct sets of step-by-step instructions, algorithms, independently or collaboratively. When you do something like this, I would do this as a whole group first. And for example, we're telling a story of Goldilocks. Do you all know Goldilocks? Mm-hmm. Goldilocks, if you really think about it, is kind of scary, the fact that she went in someone's house. It does say in this version that she did not first, so I guess that's important. But she goes into her neighbor's house, and then leaves their things, and then gets chased out at the end. But in kindergarten, we have to know about a story, and we have to talk about the beginning, the middle, and the end. Oh, what a great idea. Beginning, middle, and end. So, for example, we could go ahead and we could physically put little pictures down there. The children could draw pictures of a story, do a storyboard, and talk about the sequence that they happen. We right now, I have them up here, and we have a robot. And this robot we could code to go to the beginning, the middle, and the end. And if I was in first grade, I might want to use ordinal numbers. So I would put more down here and figure out what first, second, third, fourth, fifth might be. So you can elaborate or make more elaborate whatever you want to do. You can start at something very basic. I could have gone ahead and just said, okay, I'm going to the Codeorg information, pull out a sheet, show it up there. Kids can do it, we'll go on. Or you could be a little creative, make your own. And something like Scratch Junior, they could design their own backgrounds for the story and have to put those in order or sequence or flip the sequence around. These are all things that you can do. So we have 2 K2 teachers here today. Where are you again?
Do we have a volunteer K2 teacher?
We have a volunteer. Would you like to come up and try our little Spiro? And you're going to be on TV too. So you'll be famous, as famous robot driver. Now we need to find
There you go.
the right iPad.
There you go.
The Spiros are very easy to operate, but right now I'm just going to have her drive instead of coding. See, I'm not going to give too many horrible things to you.
So the driving is basically like you're using your finger to control if you've not used the Spiros, but then you can go in later in the program and actually do like block coding if you wanted to actually give it a set of directions. And I did this, I have a 3.5-year-old, and so I took him home and he was really good at driving it and figuring out. And, you know, I had to help him aim it the first time, but these little people are amazing with this technology.
Now, she would have to go to what happens first, or else when he ran to there. Now, the first thing is she's sitting at a table eating some gruel or some soup. And then the first one, she goes to somebody's house and she's lost. And then the one over here is, he's still coming back. He is, they found her in their bed. So let's say if you could drive Spiro and if he was out here, where would he be? Where would he go first? To the middle one. So you were aiming in the correct thing. So very good. I'm very proud of you. And then where would you go next?
To the first one.
Okay, because she's eating their testing their food, which was too hot before. So you would drive there, and where would you end up?
The last one.
Okay. Well then I'm glad you're in the right place. And you're gonna do a really good job. That you need to thank her. So this is something very simple. It's pictures stuck on little cups. You could do this with elements, things like states of matter. You could do different figures, different colors, sort that way. Kids would love to drive in code.
You want your first grade spreadsheet?
Well, yeah, we'll pop the first and second. Let's go to second because they have the most.
Okay.
Most everything is the same on these. The computer, the internet safety, computing systems. Basically, you're just telling people what different computer parts are, which is important. Build on it. Have the kids report out what the parts are. Just as if and what are the rules to using them? We have a big problem with equipment that kids sometimes misuse equipment. Part of computer science would be telling them how to use it properly and have them monitor themselves, monitor their groups, and be able to tell us when we're not using things properly. And as equipment lasts longer this way. So what computer science standards are things you already do when you tell in your classroom. But just make sure that you're saying, well, this is computer science, so that kids are aware at a young age that there is such a thing as computer science, because it is part of the workplace, and it's a place they're all going to go to. By 7th grade, computer science is going to be more what you think about with computer scientists. But we want these kids to be ready, to know that these activities exist, whether or not they're ever a coder. They don't have to be a coder, but they need to be aware that it happens. And when they work in the workplace, they're going to be working probably with coders. They have to understand basic things about what they do. Do you want to go ahead? Is that second grade up?
That's the second grade, yes.
The second grade is a little different because they get a little more involved. They go ahead and they have things called like identifying events, loop sequencing. Is that some of the things you were talking about that you don't necessarily know what those are? Well, an event is making something new happen. For example, if you're running a program, the start or the flag or the go, that's an event. So basically, it's something that causes something else to happen. Looping just means going over and over again. It also is a time-saving device. It's a good thing for kids to know that you don't have to do everything the long way. Short way is a good way to do it. And using sequencing, things that go in a certain order. Kids in Virginia in the years past have had some trouble with sequencing and having problems with patterning. And so this is a great boost for all of us. Whoever wrote these, I mean, they're based a lot on the national standards and information at Codeorg. They really did a good job. What else do I want to tell you about? Oh, this also asks for using data. How many of you use data in the classroom? You ever heard of that? Data, they can manage data. They can use a spreadsheet. I had kindergartners using spreadsheets 20 years ago. They can do basic spreadsheets and charts. They love it. So embrace those kind of things. Those are a standard that you all can do. You can do it whole group, or you can do it individually with something like Sheets or Excel. And just, of course, whatever their age is, limit what the information is.
All right. So moving on to the 3 through 6 standards, these, of course, get a little bit more involved as the students grow because we're ultimately preparing them for their computer science courses in high school, middle school, things like that. So as I said before, I kind of split these up into the reporting categories. So looking at the algorithms and programming, and it says the student will construct sets of step-by-step instructions, algorithms, both independently and collaboratively using sequencing, using loops, using events. That's what she just talked about. And all of the standards K through 12 pretty much start out that way. And the word algorithm is something that I didn't hear probably till high school when I was in maybe pre-calculus, calculus, but I've started using that with my 6th graders now because I want them to understand that when we add, subtract, multiply, or divide, let's say integers, there's an algorithm behind that. There is a reason why we do what we do. Positive times positive is a positive, negative times positive is a negative. So looking at grades 3 and 4, think about sequencing, loops, and events. Every math standard grades 3 through 5 now, at least. I think 6th grade has finally gotten rid of the patterns, but we all do patterns. Whether they're pictorial patterns, whether they're numerical patterns, whether they're Fibonacci sequences, there are some sort of patterns. Multiplication is a pattern. And when you start teaching multiplication, 2nd, 3rd grade, you have them draw like the tally march, right? The sets, that's a pattern. And that's exactly what coding is doing. It's extending those patterns, it's creating those loops. It's trying to figure out where is my starting event? What do I want to make it do next? Solving word problems. Every grade level, K through 12, pretty much, whatever math you're in, you're going to solve word problems. And like we stated at the beginning, students can sometimes get the first part if it's a 1-step, okay. And sometimes they can get the second part if it's multi-step. But like, what if it's 2 or 3 steps? Or what if it's the vocabulary in the word that they're having trouble with? Coding and computer science can help with this as well. And these are things that you're already teaching. But maybe they don't understand how to read the word, not read the words, but maybe they don't understand how to interpret that word problem. But you give them something that they can code with, and their brain starts thinking a different way. Vaughn and I both have, as we've been doing this together, I used to really bad like put together things like with a set of directions that he said put part A, part B, and screw part E. I was horrible with that. But now that I've done some of this coding and it's changing the way that I process the steps, I'm a whole lot better at those things now. And Lisa is as well. I mean, we both have had that shared experience together. Moving on to, grade 4 math. Again, we're still multiplying, we're still solving word problems, we're still doing sequencing. And now we're talking about, okay, how do you create a step-by-step set of directions to do something? Could you give somebody else step-by-step directions on how to add fractions or whatever it may be? So at this point, we're moving past the teacher telling the student how to do it and the student telling themselves and then ultimately sharing with others how to do it. With reading, okay, so we think of computer science as math and science-based, but they have to comprehend what they're reading and be able to retell. That's sequencing. Computer science is all about a sequence. So we're sequencing, we're editing, we're giving them story maps, flowcharts, we're comparing and contrasting. We're giving clear and concise directions. That it all goes together. It's cross-curricular. For science, we have to identify and classify characteristics. Again, we're comparing and contrasting. History is not up here because it just couldn't make it fit, but history is a big timeline, right? It's a big series of events. And if you can teach them how to quantify those things into a series of events, they're going to be very successful with their math, science, history, social studies, as well as their computer science. Go to the next one. For 5th and 6th grade, and I have 5th and 6th grade, so I see what they need from 5th grade to make it in 6th grade, what they need from 6th grade to make it in algebra, or whatever they make next. But again, it's all coming back to the same thing. Sequencing, loop, events, multiplication, fractions, order of operations. There's your step-by-step directions. So they can always get the parentheses and the exponents, but then when it comes to multiplying and dividing and you have to do it from left to right, you don't always multiply first, that's where the hiccup comes into play. So when we're using computer science, we're using coding, we're bringing in those skills that they should already know from math. Math 6, one of the new things this year is rates. It came from 7th grade, and we taught that first in our district, and I thought this is the worst thing that we could have taught first. They don't get it. But if we taught coordinate grids first, coordinate planes where we can teach those graphs and things, it would have been a lot easier for our students. So now I'm going back and kind of reteaching those things. Coordinate planes is something in 6th grade that we focus a lot on, and Scratch, which I'll talk about a little bit more in a minute, is based out of a big coordinate plane. And so when they understand the concept of how those positive and negative numbers move, they can really do a lot more with their activities. Again, reading and science are very much the same across the grade levels. You're sequencing, you're editing, you're doing your story maps, you're classifying, you're comparing, you're contrasting. These are all things that you're doing in your classroom. And think about what Lisa did with the K2. You can certainly broadcast that to your 3-6 students, but now you're having them code, not just drive Spiro, you're having them code and giving the sequence of the story of events that you're doing, that they're doing on their own. So you're giving minimal directions and they're creating their own storyline based on their coding with their Scratch or their Spiros or whatever it may be. Go ahead. Data and analysis. Now this does lend itself more to math and science in the classroom. We all use data in all of our subjects, but the students are really going to see the data analysis when they're extending their patterns, they're making predictions, they're solving their word problems, creating models. In third grade, you do a lot of plant life cycles, things like that. So you're creating models. Well, that's what we're doing with coding. We're creating models. We're making something happen. Fourth grade, we do the solar system phases of the moon. Even if you do the Oreo cookie phases of the moon, that's a computer science standard because you're modeling, you're modeling a sequence or a series of events. They're looping patterns, things like that. Making inferences. I know that when I teach science, making inferences is a struggle for students. I don't understand why. I mean, I don't personally understand why, but that is a struggle. But making inferences about what's going to happen next if you're coding or you're doing block coding or whatever it may be can kind of help them think through those processes a little bit more. Go ahead. And then grade 5th and 6th, again, we're covering all the same standards. Clear, concise steps, order of operations, interpreting graphs. Well, they do that for math and science. And for your coding, like she said, with the Excel spreadsheets, you can do that with your little people, and then they can make it into their line graph or their bar graph or whatever they need it to be at that point in time. Go ahead. Now, computing systems is another reporting category, and this applies to all grade levels. This is something that you can do K problems. And we try to kind of make them uniform so that they don't have so many things to remember. But again, we tell them, don't share them with your neighbor. We have social media issues. I teach 6th grade. Instagram, house party, whatever, the apps that I probably don't even know about. And then they bring problems that occur into school. Well, last year I had an instance where a kid said, such and such logged into my account, posted a picture of stuff. Well, honey, how'd they log into your account? Well, I gave them a password because they didn't have one. Okay, well, let's think about that. Was that the smartest choice you could have made? So we have those conversations with them. We'll do some cyberbullying things throughout the school year. And we just want to encourage them to use it appropriately and not share their information because that's where you cause your data breaches. That's where we have major issues. Go ahead. And then networking the internet. So this is the easiest one that you can probably do without having technology. Networking is simply getting together with other people, just like we're doing now to share information. And our kids today have a hard time with that because they are so stuck to their electronic devices that they sometimes don't know how to interact with one another. So I see this as a way to develop peer relationships using group activities in class and encouraging writing activities where they have to respond to one another in an appropriate manner. In my math class, you know, you solve these first 10 and you solve the next 10, and then we're going to get together and you can, you know, you figure out who made what mistake or if there was a mistake made. And then you're encouraging that proper networking, that proper correspondence with one another. And it's not, oh, you did this, ha, ha, ha. Integrated into your, but what are some tools that you can use? So we're going to lace it all up and give you some tools. Go ahead, Lisa. This is what my classroom looked like. These are actually my photos from last year because this was a more complete representation. I have 15 iPads that I do share with other people. I'm not selfish, I promise. I've got these lovely boards that I brought this year's with me. And what I do is I set up all of my classes in Code.org and actually let my students do the courses A through F that walks them through step by step. And then I document like how far they've got. And I hang these in my room so they can see their progress, their classmates' progress. And some of them like will turn it into a competition. Like my little fellow that's this is one of our other TRTs, Felicia Moore, who would come over and kind of help walk us through. She did some digital breakouts for us last year. Go ahead. So this one is unplugged activities from Code.org. Has anybody used unplugged activities from Code.org? Okay, so I brought some of them with me if anybody wants to, you know, snag a copy of them or whatever before you left. But I love these activities because these are paper pencil activities, but you're still coding. And with this one that I have here, it's different from the one up here, but this was called Kid Fax. Most of our students don't know what a fax machine is because they're not used. I mean, they're used, but they're not used like all the time because everything's done through email. And so this one had like a little sheet that the teacher read and explained that fax machines work like in black and white numbers, you know, black versus white, and then how many spaces you skip. And so once I read that and I did kind of a sample, then they had to code these pictures. So they ended up with a mug, a planet, and like a baby face, as I call it. But it's very interesting to see. It was like a 50%, half of them got it, and the other half really struggled. 4 white ones, 11 black. Wait a minute. Just black, number 4 white. Like they really struggled with that. But then in the end, I mean, I think I would say 80% of my students were successful. It just took some of them a little bit longer. So I absolutely love the uncoded activities. They're free from Code.org. The UK site for Code.org, I think, has some of the best ones, to be honest with you. I do. But, you know, these paper folding, I will tell you that I'm like the world's most horrible origami maker, but I can like fold the paper from Code.org. I can get that. You know, I can make that happen. Go to the search bar on Code.org, search unplugged activities, and then they all come up and you can sort them however you want to sort them. This one is Spiro, which is the little robots. Edges.spiro.com. You have to have a teacher account, but they have ready-made lesson plans, ready-made codes. And I'm going to show you an example of one that we did last year. When we did we're going to have to get out of this and go to my pictures. When I covered the solar system with my 6th graders, there was a ready-made Spiro lesson on the planets. So we set up the sun in the center, and then we coded each planet to move. And let's see if this one's going to. We didn't quite make it, but we got really close. This was probably the best one. So some of our planets were a little bit out there. They kind of got lost in the Milky Way or something.
But we had to modify, or the students had to modify speed, distance, all those things. You know, it was a pre-organized program, and that each planet was a different color. And we had to actually write on the Spiros to make sure we knew which.
We did. We had
planet.
to like take a marker and write which one was Mars, which one was Jupiter. The Spiros Earth, and then the students had to go through and figure out what the speed and distance would be for all the other planets based on that one. So there was a lot of critical thinking involved with that particular activity, and they absolutely loved it. Like, we didn't perfect it, and so this is done after us as well as the end of the year in May, and they were like, can we do the Spiros again? And finally I had to turn them back to the library, and they're like, but we never got it right. You know, they really wanted to be successful with this. So it's, you know, it's a great way. This website is a great way. And like I said, they have ready-made plans like that one on there. So you could go in and search solar system. You could go in and search butterfly life cycle. And you could find different things to help your students with that. Let's see, this one is Scratch. And I'm going to show you some examples of Scratch as well. I don't think it takes 1 day to wait for approval anymore. It just kind of depends on how busy their site is. It used to take 1 day to wait for approval to get your teacher's site, but we use this one, and I have used this one. So because I do most of the coding, I did a reading lesson. Lisa and I did a reading lesson for my partner teacher using Scratch. And this is the block coding that the students kind of pull over. And I have found through the years that when the students do the Codeorg courses, like A through F, that I'll show you in a minute, they are more successful with Scratch, because then it kind of makes sense. Like, they understand why they're pulling an event and why they're pulling a go-to and why they're pulling a X, Y, and Z. And Scratch is based off of a huge coordinate grid. And so we print these out the first time we do it with the students. And this is just a big coordinate grid. And so, like, a lot of the times here is like their initials. So they'll put like a big A or a big B, and then they have to go in and code those points in Scratch in order to make the first letter of their first name. This year I started with something a little more simplistic and gave them a step-by-step set of directions, which I have a few copies of it here if anybody's interested when we're done, of cup stacking. And I loved this one. Lisa actually worked with our PE teachers because they wanted to learn how to do Scratch. And they did a cup stacking activity, because this is something that you can do in your PE room with the cup stacking. And that's what we made it do. So I showed the students that first, and then I went back. So I'll show it to you one more time. Stop. Express spacebar resets it, right? Yep. Let me go back. Let me see inside. So we had to put 3 different sprites down here. And then this is the code for the first sprite. We had to code the second sprite. We had to code the third sprite. And then each sprite had to have its different coordinates about where to go. So we had to, so this was the basic one that I started off with this school year, showing them Scratch after they had successfully completed a course in the Code.org site. So we did, in years past, I have done the letters, but this one is cause and effect for an English standard. Our students struggle with cause and effect in 6th grade. So we told the reading teacher, we'll put that into our coding and we'll do it. So we had students who, oh, this one's ratios. Sorry, I lied. This one's ratios. I did ratios. This one is actually a game. So 10 black marbles, 4 blue marbles. What is the ratio of all marbles to blue marbles? So they actually type in the answer, 14:4. If they get it correct, it gives them a point up there in the corner. And then it goes to the next question. So there's 15 black marbles, 17 blue marbles. What's the ratio of blue marbles to all? Well, if they got it wrong, let's say they just put in a wrong answer, it takes a point away. So we had to teach them how to code that, how one question has to respond to another question. So that one was really neat. They enjoyed that one.
It's a good introductory game.
It is. It is. And I was trying to get the cause and effect one. Here we go. So here's our cause and effect. So this was our English standard. And these are, you can have them to create it, and then their friends they can exchange computers, and their friends can go in and play these games essentially. So they're talking back and forth. Can you help me with cause and effect? Come on, guys. There we go. So he gives the definition. And we've got our wait times in here. So some of the waits are a little bit longer or shorter than others. Check out my crib. So now they're going to change background. So they had to program it to change background because they're going to go back to the castle. This is a 1,000-year-old castle. Why do you think it still looks so nice? That would be the cause, The cause is that you clean it all the time. And then it changed backgrounds again. And, you know, for a first time sixth grader doing this, I mean, most of these students, this is the first time they've ever done it. They're doing pretty well. You know, they're doing, you know, we teach them the basics and then they go, yes, ma'am. Sure. For that one. Yeah.
And we start out a lot of things using broadcast and receiving messages.
So this is for the boy. This is the code for the boy. And then the ghost, of course, has his own set of code.
Mm-hmm.
And so what we did with this particular activity is we kind of had them pick their sprites and we walked them through the code, like for the first one, and then we let them create their code for any, you know, any forthcoming. Like we required them to have, you know, you had to have 3 questions, or you had to have 2 questions, whatever it may be for that assignment. So everybody, you know, had the same requirements, just, you know, their questions were going to be a little bit different. And for this particular activity, we also started out a little bit unplugged, and we had them to write if-then statements, because that's a science standard and it's a cause and effect statement. So, you know, we got if-then statements. If you work hard in your job, then you'll make good money. If you don't do your homework, then you will get in trouble. So there, again, these are unplugged activities that are dealing with these coding aspects of things. And then we have computer science first with Google. This is one that is free, am I right? And this one works on the iPads, correct?
I think so.
This one works on the iPads. And they've created some lessons that are already in Scratch for you if you wanted to use those lessons that are already created to kind of to guide you and get you started. Khan Academy. So this one is one that we use after they finish their Codeorg courses and we want to take them into Java or take them into something, you know, a little bit higher level. We'll use Khan Academy because it does speak a slightly different language. But if they've got those basics from some of the other sites, this is really, really good to extend that knowledge. Definitely, I would say more geared toward middle school, upper elementary school age, definitely. Swift Playground and iTunes U, very friendly with the iPad. K2 is successful with this, wouldn't you think? Okay.
It's more the
more the upper
grade,
grades.
yeah.
Okay, more the upper grades. But these are apps that can be downloaded and then you can, you know, start them off, you know, slow. You can do whole group, things like that. Let's see, Codeable is definitely entry, very, very simplistic, very user-friendly, iPad, Chromebook friendly.
But you have to pay for other parts of it, so only a little bit is free.
Only a little bit is free.
But it's nice
Yes.
what it does have.
And then Code.org. And so this is the part that I really start my students off with. And I use this kind of an incentive in my classroom as well. Once I get them hooked into it, it's like, yeah, you finish your work, you can do this. Or your kids, the behavior problem, they're really good at this a lot of times. And so you use this as an incentive. So what you do is you set up your classes. Each student gets a like a funky password, and you go in and you give them their link, and then you can track what they're doing. So I can go in at any time and see that, you know, Johnny has done lesson 4, lesson 6, lesson 7. He's on lesson A, you know, 8 of course A. And if he's on lesson 8 of course A for like weeks, I'm like, John, at coding time I'm giving you a class. You know, what are you doing there, buddy? You know, what's going on? So this is a very friendly, free account, and this is the one that my students have to really like the most. I mean, I had students last year, several that finished all the way through course F and then moved into Khan Academy very successfully with this. And it's covering all of those computer science standards. It's helping with the critical thinking skills. It's helping with the problem solving skills. So again, Code.org, free coding, free cybersecurity, and free unplugged. They have really, really good cybersecurity lessons that you can look up for the upper elementary. NetSafe is definitely geared toward lower elementary. NetSmarts is lower elementary. But the cybersecurity lessons on Code.org are very, very good for those upper elementary school students. Scratch that we just talked about uses the coordinate planes. It allows them to, and you can create the games and interactive projects like I showed. So to tie it all up, because we want to leave some time for some questions. The computer science standards are not something else that you have to teach. You're already teaching it, and I hope that you found this useful to give you some tools to include this in your instruction or to take back to your school and share with your teachers. They're an enhancement of lessons we already teach, and we allow students to become safe and responsible users of technology. So on the screen, you see our email addresses. We are also going to post this to the VSTE Share site. And at this time, if you have any questions, concerns, we would love to help you address those at the end of our session. Yes, ma'am.
Just like this is stated for teachers,
Mm-hmm.
like you're saying, demystifying it. Then you have a lot of tools.
Right.
That's another challenge for them. So if you could pick like your favorite K2 or maybe your K2 kind of the first one.
Code.org is my favorite 3.5, just because I'm one of those teachers that likes like step-by-step things. So the fact that they can progress through different levels, I like that. Yes. Go ahead for your
I'd
K2.
probably say Scratch Junior for me, but I like Scratch Junior just to teach anybody before they go to Scratch. I think it's a good way to begin coding, not very threatening, and then Scratch, I'd say second part of second grade.
And Scratch Junior's only iPod?
No, it's Android, it's iPad, it's Chromebook. So you just need to get the, go to the store on your Chromebooks and get it. They still haven't made it for the desktop or for your laptop, even though I tried some sneaky ways to see if I could make it work so I could share with you. It's not functioning. And then Scratch, I've been using Scratch since 2007, since the year it came out. I also like Alice, though Alice I haven't been able to get to function. That's for a little bit upper elementary. I like the 3D concepts in Alice, so I'm going to try to work this week on getting Alice to work in Windows 10. It was created at Carnegie Mellon, and they do a lot of robotics up there. So I'd like to see if I can get that. We'll post that on there if I have good luck with it. It is a download. And it hasn't functioned well probably the last couple of years just because of the nature of the changes of software. But if I can get it to go, I'll let you know. But kids love it. You can actually make even the tail on a dog wag. So it's very, very 3D, very interesting looking.
Any other questions? Yes.
When you do your Codeorg, do you try to time your unplugged activity?
I just pick the ones that I like, as far as the unplugged or that I think that group of students will enjoy. So I don't necessarily correspond them with what they're doing in the courses. Yeah.
And in the little packet that we'll have in the information has a lot of those unplugged activities in it already, so you can just print those out from that.
Right. Yes.
How many different kinds of robots have you all used? Do you primarily just use the Spiros, or do you
I primarily use the Spiros. We've got some things that do we have the bug things? K2. Didn't y'all just get the new set of bugs? No?
No, no.
No, okay.
I've had a lot of robotics experience from the past. We also use those Legos, but I used to work for a company that we would provide robotics education to kindergarten. So whatever they had to teach.
You all have a good experience with the Spiro so far?
Yes, yes.
I'll tell you ones I like the best. Spark Plus. I've got a set of Sparks. 2.0 Sparks, yes, okay, Spark Plus, if I had my druthers, that's what I would purchase. For charging ability, for maintenance, everything else, they work pretty much as you go. And we do art classes with them, we do PE, a lot of our teachers bring those in. And we have a lot of Spiro painting.
Yeah, we painted with the Spiros in a summer session with a group of teachers this year, which was a lot of
But
fun.
we also did it with grades 3 through 6, all the classes got to be. And our teacher's thrilled and she can't wait for more things to happen. Can be a little messy, but it worked out very well.
Yes. Any other questions? All right, thank you all so much for coming, and we really hope that you enjoyed it and got a lot out of the session. And again, I've got copies, like if you wanted the cup scratching or the cup stacking scratch activity, I've got a few copies of things if you'd like to grab them.